Hello, welcome to today's lecture. For today, we're talking about colonial morphology, and that is under bacterial identification. It's the first step in trying to identify microorganisms. So, what do we mean by colonial morphology? Don't forget that bacteria grows in colonies. So, to identify them, you start by identify or understanding how the colonial features look like. It's a guide to helping you identify an organism because you don't want to waste reagent doing random tests. So you want to ascertain what features, what colonial features does this organism have as a guide to telling you what this organism may be, or keep in mind what genus this organism may fall into. So for today's lecture, we have chocolate agar and we have an organism, a 24 hours culture, as you can see, a 24 hours culture here. So the question is, what organism is growing on this chocolate agar? As you can see, each of these dots, this growth you're seeing like that looks like dots, they are called colonies. Each of these dots are called colonies. So in trying to identify or look out for the colonial features, you pick just one of the colony, one of the bacterial colony, and try to understand its features. What does it look like? What are you seeing? So there are some parameters we use to check in trying to identify colonial morphology. So first off, this is a chocolate agar. That is, it is an enriched media. An enriched media is one that has additional nutrients that is added to it. So we already know this is an enriched media, and enriched media is a routine media, but can also be used for organisms with special needs, fastidious organisms. So first things first, we know the media is chocolate agar, an enriched media. The next thing you want to do is to look out for the characteristics as per colonial characteristics that we are to look out for. The first of which is size. How do we check for the size of a colony? That is the question. Looking at this colony now, how do you check for the size of this colony? Don't forget that the material we have here, you can use your meter rule. The ruler, our meter rule, is graded in centimeter. Our meter rule is graded in centimeter. And you know that the colonial size that we want to look out for should be in millimeter. You are checking the millimeter in diameter, it should be in millimeter. And now the meter rule is in centimeter. And you know that centimeter is greater than millimeter. Do you understand that? That means 10 millimeter will make 1 centimeter. So with that conversion in mind, it will help us to make do with the meter rule we have, since we don't have a meter rule in millimeter. So that means when you want to measure, you want to start from the point of gradation. Don't start from the edge of the ruler. You want to start from the point of gradation. That is the point where you see the first line. That is the point where the measurement starts from. So this first point now, this first point you're seeing, let me use something a little bit smaller to point so that you understand what I'm saying. This first point is the beginning of the measurement. For each of these tiny little lines in between, that is 1 centimeter. Because from this first measurement, from this first line to where you have 1 is 1 centimeter. And we already said 10 millimeter make 1 centimeter. So in between this 1 centimeter is 10 millimeter. That means each of this line is 1 millimeter. Each of this line will give you, in between each of this line will give you 1 millimeter, so that you can use this ruler as a makeshift for the meter rule that's supposed to be in millimeter. So what do? Assuming this is your meter rule, I want to make it a little bit bold. This is your meter rule. This is how it looks like. Then you have 1. This is what you have. So what I'm trying to explain is this. This is the ruler now, the meter rule. This is the beginning of the graduation. This is the beginning of the graduation. This is where you start your measurement, not from the edge of the ruler. So from this first line to this line is 1 millimeter. From this to this is 1 millimeter. From this to this, another millimeter. From here to here is another millimeter. From here to here is another millimeter. From here to here, another millimeter. Such that at the end, when you get to 1, you are having 10 millimeter. So this is 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter, 6 millimeter, 7 millimeter, 8 millimeter, 10 millimeter. So, assuming the organism you are trying to identify, you bring the ruler and place it just on top the lid. You don't need to open the plate, you just cover it and place the ruler over one of the colony. Assuming this is the colony you are trying to identify. So, assuming the colony you're under identification falls between the first measurement, the first line of measurement to the second, this is 1 millimeter, because we already said from the first graduation to the next is 1 millimeter. So, assuming you place your meter rule and it falls this way, you know that this is 1 millimeter. So that is what we are going to do now. So you get your test organism and you pick one colony that stands out. You just pick one colony that stands out on its own. It tells you for easy measurement. And then you place your ruler over the plate just like this. And you measure. So you see what we're trying to do here? All right, you see that the first line of the graduation is at the beginning of this particular colony now we are trying to measure. And you see it falls, the end of the colony falls on the end, on the second graduation, making that is 1 millimeter. So for this colony now, the size is 1 millimeter in diameter. So next on our colonial morphology is to check the shape. The shape of the colony. The shape of the colony. Now, a bacterial colony can either be round, either you say it's round or regular. It's either the bacterial colony is round or you say the bacterial colony is regular. If it's not either of this, it's irregular. Irregular. The bacterial colony is irregular. Round and regular are the same word, so you can use any of them. So it's either the bacterial colony is regular or irregular. So what do we mean by regular or irregular? When a colony is regular, it is round. It is whole. So for a bacterial colony to be regular, it should look like this. You say the colony is regular. But for a bacterial colony that is irregular, it looks like this. Huh? You say it's irregular. It takes no definite shape. So it's irregular. So the next, now we'll look at this plate. Now, looking at this plate, what is the shape of this colony? What is the shape? You find out that it is round, it is regular, it has a definite shape, so it is regular. So just like what I explained, find out that the colony is round. Next, the next colonial feature we want to look out for is the edge. The edge. Now, it's important to note that the edge of the colony determines the shape. The edge of the colony determines the shape. You know, every object that has matter occupies a definite space. So the edge of the colony determines its shape. So if the colony is round, that means the edge should be entire, because the edge is entire and it has a whole circumference. That's why we can say it is round, because the edge is entire. So the edge determines the shape. So the edge can either be entire or crenated. So for this one now, we'll say the edge is entire. And for this, which is irregular in shape, we'll say the edge is crenated. So that's for edge. Now the next thing you want to look out for is the color. You want to look out for the color. What is the color? Now the next colonial feature I want to look out for is the color. Now, different bacterial colonies with the color they take up depending on the organism and the type of plate it was inoculated on. Now, for this is a chocolate agar, like I said earlier, and under close observation, you find out that this colony looks whitish. This colony looks whitish. It's white. So you say it's white on this chocolate agar. Now there's some colony that can look gray, or some colony can have different color depending on several factors like the media it's cultured on, if the organism produces pigment, if the organism ferments sugar such as lactose, and several other factors. So for this particular plate now, the colony is white or whitish in color. Now the next factor or the next colonial feature that I want to look out for is fermentation. Fermentation. Although the plate we have here is not a plate containing sugar, or does not contain lactose or any of these sugars, but we're going to still talk about it. Now, there are different plates that contain different types of sugar, such as lactose, glucose, sucrose, mannitol, name it. We have several types of sugar. Now, the ability of an organism to break down those sugars present in the media to release acid gives a certain coloration which changes the color of the colony and it expresses as a fermenter of such sugar. Then, like in the case of cysteine, lactose, electrolyte deficient agar, you find that organisms like Escherichia coli would ferment the lactose on such types of differential media to give a yellow coloration. So in that case, now you find that the fermentation affects the color. So you see, that's why I said the color depends on several factors. Now in this case, there is no fermentation because this plate does not contain lactose. So we'll move ahead. The next feature to look out for is the elevation. The elevation. What do we mean by elevation? Now, a bacterial colony can either be raised or flat. What do I mean? Assuming this is the upper part of the media. Let's assume this is your petri dish containing your media onto which you cultured. And then after 24 hours, you are having a colony such as this. You would say that this colony is raised. If the colony is above the media on which it was cultured, you will say it is raised. If the colony does not rise above, just remains like this, you say it's flat. So the elevation for bacterial colonies can either be raised or elevated. Now we look at test organism or under observation. Now when you want to check for the elevation, it's best you keep it at some certain angle. So here you have to place the media above, a little bit above your eye level, so you can get the elevation. You can see now that this particular test organism under observation is elevated. Like I said, the test colony can either be elevated or flat. So if it's not elevated, it is flat. And for this one, you find that it's elevated. It has a hyperbolic shape above the media under identification. So you find out that for this media, this test colony now, this one is elevated, just like I rightly explained earlier. All right, the next colonial feature that you can look out for is the odor. Now, there are some organisms that have distinct smell. There's organisms like Proteus. Proteus has a stockfish smell or a rotten egg smell. So how do you check for the odor? You do this by passing quickly over your nose. You don't have to put it in your nose. Just pass quickly over air to perceive if the organism has a characteristic smell. So passing over does not have a characteristic smell. This organism does not have a characteristic smell, unlike Pseudomonas that smells like a new slippers. So those organisms have characteristic smell. So that's how you check for odor of a bacterial colony. Next is pigmentation. Now there are some organisms that carry a phenomenon known as pigmentation. They release pigment on growth after inoculation. An example of such organism is Pseudomonas. Pseudomonas releases two pigments, your Pyocyanin and Pyoverdine. It releases two pigments. So those pigments give rise to a color production. So it gives the test colony a certain greenish coloration. So that's why I said earlier that pigmentation can also affect the color of the test colony. So you check the media. Does it produce pigments? You check this. This does not produce any pigment. Like we already said, the color is white. So that's for pigmentation. Then the next is hemolysis. Hemolysis. Hemolysis happens to be one of the colonial feature that can be looked out for certain organisms of hemolytic that have hemolytic nature. That is the ability to lyse red cells. Don't forget that I spoke earlier about enriched media such as chocolate agar or blood agar that have about 10% blood added to make them enriched for organisms that are fastidious in nature. Now, there are some of these organisms that clear on growing on such enriched media, clear the blood which was added onto it, making the media either transparent or greenish in nature. That's why we talk about alpha hemolysis, beta hemolysis, and gamma hemolysis. So some organisms such as Streptococcus pneumoniae would carry out alpha hemolysis, creating a greenish pigment on chocolate or blood agar, while Streptococcus Pyogenians would do a beta hemolysis. That is a complete clearing of, if this were to be strep growing on this plate, you find out that there will be a complete clearing. It will eat up this color you're seeing here, and the media will become transparent. So for such organism, you say that it's carrying out, you name the type of hemolysis it's carrying out. But for this, there is no hemolysis. But I'm only mentioning for cases where you find such happening. So that's that for colonial morphology. Now, this is the first step for identifying a bacterial colony. It helps you because already you should have a picture of the colonial morphology of various organisms. If you check your lecture notes, which I have already given, you will find the colonial morphology of various organisms and what they should look like. So when you check your colonial features, you match them with any of those organisms. Which one has such size? If the size is 1 millimeter in diameter, okay, what is the shape? Is it round? Is it irregular? What is the elevation? And then you match it just like the way a criminal is looked for by policemen. That's the same way you are trying to incriminate a particular organism which is causing a certain infection in your patient. So that is the importance of doing colonial morphology. It guides you. It guides you because after this you go on to do your gram staining, which will now differentiate organisms to gram positive and gram negative. After which you will now implicate organisms that have this certain colonial features that you have found and the Gram's reaction you have gotten. It's a guide to telling you the biochemical test to carry out after that. So I believe that with this, you have learned comprehensively how to do colonial morphology.